There was once a girl who loved horses. She rode every weekend. She was strong, active, and fearless. One day, she fell off her horse. At first, it didn't seem unusual. A fall, a few injuries, something that should heal, but it didn't. Her wound took longer than expected. Her joint became painful. A small movement caused damage. Over time, the girl who loved the sport became someone who could barely leave her bed. Her family did everything they could. They went from doctor to doctor, from country to country, searching for an answer. Eventually, she was diagnosed with a condition called Ehlers-Danlos Syndrome, or EDS. EDS is a genetic condition that affects the body's support tissue. There is no cure. And for one major subtype, called hypermobile EDS, doctors don't even know the genetic cause. All they could offer her were painkillers and instruction to limit movement. So, what was going wrong? The answer may lay in collagen. Collagen is the main structure protein in our bodies. It's made by our cells and acts like the internal framework that holds everything together. You can think of it like the fibers in a rope. In healthy tissues, collagen fibers are well organized and strong, but in people with EDS, evidence shows that this structure is disrupted, weakened, disorganized, and fragile. What we don't understand is why. In hypermobile EDS, patient cells, which we call them fibroblasts, may be actively changing the collagen around them that may be remodeling it incorrectly, weakening the tissue from the inside. My PhD research asks a simple but critical question. Do fibroblasts from EDS patients change collagen differently than healthy cells? To answer this, I create collagen matrices in the lab that closely mimic human tissues. Then I place fibroblasts from EDS patients and healthy individuals into these matrices and observe how they reorganize the collagen down to the nanoscale where collagen fibers are formed. By controlling and aligning collagen structure, I can isolate the effect of the cells themselves. Why does it matter? Because if we understand how EDS cells disrupt collagen, we can begin designing better tissue models, better therapies, and eventually better ways to support healing, not just managing the pain. For patients like that girl, this research is not about riding a horse again, whether she can sit up, walk, or one day return to the life she loved. My work aimed to understand and eventually correct how her cells beat the very fabric of her body so that the fall doesn't become a lifetime sentence. Thank you.